The title of this notes is Related Rates, and the outcome is that I can solve problems involving related rates, and that means that you're going to have to create, interpret, and solve differential equations. So we have some steps here. This would be the tell side if you were going to do tell show. So whatever scenario you have, you're going to have a shape that you're going to want to sketch. And then secondly, you're going to want to define all of your variables and rates, both the ones that are given and the ones that you're trying to find. From there, in step 3, you'll create an equation. And because we're talking about rates, a rate of change is a slope, so we need a derivative. So then we will derive the equation. Then we're able to substitute and solve. And lastly, we need to go back and make sure we've actually answered the question and interpreted the solution. Because these are word problems, they're going to require answers in complete sentences. So we're going to do 2 examples together. So here's the first example. The length L of a rectangle. So as soon as I see rectangle, I'm going to make a sketch. And it says the length L is decreasing at a rate of 2 centimeters per second, while the width W is increasing at a rate of 2 centimeters per second. When L equals 12 centimeters and W equals 5 centimeters, at what rate is the area of the rectangle changing? So I'm going to label the length and the width. This is my sketch. And I'm going to define all the variables I have. So I was told that the length is decreasing at a rate of 2 centimeters per second. A rate is a rate of change. That's a synonym for slope. It's a derivative. So I'm going to write dl dt. That means the rate in change of the length over time. And I can tell that because it says centimeters per second. Because it's decreasing, it will be negative 2 centimeters per second. You do have to have units when you're doing related rates. Then we're told the width is increasing at a rate of 2 centimeters per second. The derivative, dw dt, so that's the width over time, 2 centimeters per second. So see, width, centimeters, time is in seconds. So my unit kind of helps me figure out what my derivative is. And then it says when L is 12 centimeters and W is 5 centimeters, at what rate is the area changing? So if I want the rate of the area, I want dA dt. How is the area changing over time? So I'm going to create an equation that relates area, length, and width. This is a rectangle. I know the area of a rectangle is length times width. So now I'm going to derive that equation. This is going to involve implicit differentiation. So I'm going to derive each variable, starting with the left side. The derivative of A is dA dt. Then for the right side, I have 2 variables, L and W. So I will have to use my product rule. So I will do U times V prime. So the derivative of W is just dW dt plus V U prime. That's dL over dt. So I've derived my equation, and now I'm ready to plug things in. I'm going to find dA dt, that's the thing in question, so it doesn't have an answer. The length, I want to know the rate when the length is exactly 12 centimeters, and the width is changing at 2 centimeters per second. And the width is currently 5 centimeters, and the length is decreasing 2 centimeters per second. You can keep your units in there if they help you. So I have 24 minus 10 equals 14. I'm going to think about the unit here. I need a unit for area and a unit for time. So the area, because the length and the width are each centimeters, the area will be square centimeters, and the time is still seconds. So there's my solution. So lastly, I need to interpret it. So I'm going to write a complete sentence. For that, I'm going to go back to the text. I'm going to reread the question, and I'm going to restate the question when I write my answer. So the question is, at what rate is the area changing? And that's when the length is 12 and the width is 5. So I'm going to start by rewriting that. So when the length is 12 centimeters and the width is 5 centimeters, the area, and I had 14 squared centimeters per second. It was a positive 14, so that tells me that the area is increasing. So there's the interpretation. The area is increasing at a rate of 14 cubic centimeters per second. So we're going to look at a second example. It's going to be a little bit more complicated than this one. This is a very straightforward example. A paper cup has the shape of a cone with a height 10 centimeters and radius 3 centimeters at the top. Water is poured into the cup at a rate of 2 cubic centimeters per second. How fast is the water level rising when the water is 2 centimeters deep? So first I'm going to sketch my cone. So there's my paper cup, and it has a height and a radius. And I'm going to define everything I know. So I know that the height of the cone is 10 centimeters. I know the radius is 3 centimeters. That's only at the very top, if the thing is totally filled with water. And it says, if water is being poured into the cup at a rate of 2 cubic centimeters per second. There's that word rate again. That tells me it's a derivative. But a derivative of what? Cubic centimeters, that's a hint. What's measured in cubic centimeters is volume. So dV dt equals 2 cubic centimeters per second. Positive because the water is being poured in, so the water level is rising. That's green water. It says how fast, it's asking me for a rate, is the water level rising? The water level is h. How fast is the water level rising? So that's what I'm solving for. When the water is 2 centimeters deep. If the water is 2 centimeters deep, that is a height. So I need an equation that relates height, radius, and volume. So the volume of a cone, and I'll tell you on the AP exam, these formulas would be given to you, is 1/3 pi r squared h. So let's take the derivative of that. So the derivative of v will just be dv dt. The right side has two variables, r and h. I'm going to split this as product rule into u and v. I'm going to need to jot off to the side though. U prime will be, I'm going to take the 2 and pull it in front. Because 1/3 pi is just a number. So I'm multiplying the 2 by 1/3 pi to get 2/3 pi. I'm going to decrease the 2 down to 1 for the exponent. I have to chain rule it. And then v prime, this one's a lot easier. The derivative of h is just dh dt. So I can finish my product rule now. So it's going to be u v prime plus v u prime. U prime is 2/3 pi r dr dt. I don't know why that's being weird. Okay, so now I'm going to substitute values in. I have dv dt is what I'm looking for. I have dh dt. I have h, and that's it. But what I don't have is r or dr dt. I do know the radius of the whole cone is 3, but we're talking about the water level. So when the water level is just 2, what's the radius there? So there's an extra geometry step here. If I just think about slicing that cone, pretend those are straight lines. There's the height 10 and the radius 3 at the top of the cone. Anywhere I go in that cone, any height that I go to will be proportional. So I can set up a proportion. R over 3 equals h over 10. That's the proportion for this cone. And I need r. I'm going to solve for r. R is equivalent in this cone to 3 times the height divided by 10. So that'll get me r. But I'm also going to need dr dt. Well, I can get that by deriving it. This is the same thing as 3/10 h. So it'll be 3/10 dh dt. So that's how I'm going to get the values for r and dh dt. So I did have to do a little extra geometry in there. So now I'm finally ready to start plugging things in. So I'm going to have dv dt, that's the thing I'm solving for, equals 1/3 pi r squared times dh dt. Oh, never mind, that's the thing I'm solving for. Sorry. I do know dv dt. It's 2. We'll go back over here and change that to a 2. Okay, plus, I'm going to move some stuff around. So plus h, that's the current height. The current height is 2, right there, times 2/3 pi r, which is equivalent to 3h over t, times dr dt, which is 3 over 10 times dh dt. Okay, so this is looking good. Remember, I'm trying to solve for dh dt. I do still have an h in here, right there, but I know that h is 2. So let me go back one more time and rewrite this again, knowing that h is 2. Okay, sorry for the weird handwriting, the weird calibration. So now I only have dh dt, which is good. So now I'm just going to start simplifying. So right here, 6 over 10 squared, I'm squaring both the numerator and the denominator, so that's 36 over 100. And I'm going to also multiply by this fraction. So this is 36 times 1, and then this is 100 because it's 10 squared times 3. Okay, so I have this weird multiplication. Remember, I'm just multiplying all the numerators. So 2 times 2 times 6 times 3, that's 72. And then multiplying all the denominators, 3 times 10 times 10, that's 300. And I also have a pi there. Okay, so these are actually like terms. So I can add them together, 36 over 300 and 72 over 300. So I'm going to add 36 and 72. I'll do that off to the side here. Is that 112? Nope. 108. I have a total of 108 over 300 pi dH dt. And I see that both that numerator, 108, and that denominator, 300, are even. So I can definitely factor out a 2. Oh, look, they're both even again. So I'm going to factor out a 2 again. And now I have 27 over 75. Neither of those is even, but they are both divisible by 3. You don't have to do this on the AP exam, but I'm just going to try to simplify these as much as possible. And then I get to 9 and 25. 9 is only divisible by 3, 25 is only divisible by 5, so that's totally simplified. So I want to get dH dt by itself, so I'm going to multiply by 25 over 9 on both sides to get rid of that fraction. So remember, you multiply your numerators together, so that gives me 50 over 9 equals pi dH dt. So the last thing I need to do is I need to divide both sides by pi. Dividing by pi is the same thing as multiplying by 1 over pi. So I finally get that dH dt equals 50 over 9 pi. The unit for height is centimeters, and the unit for time is seconds. So the rate will be centimeters per second. So I would go back and I would write an interpreting sentence, and my sentence would say, when the height of the water is 2 centimeters, when the water is 2 centimeters deep is another way to say that. The height, because I have a positive rate, the height is increasing at a rate of 50 over 9 pi centimeters per second. That's that last final step where you're interpreting. All right, so this is related rates. This is going to be the end of our notes right here.